Hi, this is Priyankesh. I hope you all are doing great. Welcome to the MCQ 1 Integration Solutions. So let's get started. So in order to integrate this integral, we have to first transform this integral into like that. Let's add 2x and subtract 2x. So this will become, this part will become x plus 1 whole square divided by x plus 1 whole square minus 2x upon x plus 1 whole square. Okay, so this will come out here, this and this gets eliminated. So this is becoming 1 into dx minus integral 2x upon x plus 1 whole square. We can further transform it like that. 1 dx minus 2 will come outside. And if we add plus 1 and subtract, and further we divide it by x plus 1 whole square. So this will become, when you integrate this, so this gets eliminated, and this will finally come out to be 1 dx minus 2, 1 upon x plus 1 dx minus minus plus 2, 1 upon x plus 1 whole square dx. Okay, so here if we integrate this, so this will come out to be x minus 2. This will come out to be log mod of x plus 1 plus 2. This will come out to be, if you take this value as, let's say, x plus 1 equals to t, so this will come out to be 1 upon t square, and finally this is coming out to be minus 1 upon x plus 1 plus c. So if we go by choices, so this is x minus 2 log x plus 1 minus 2 upon x plus 1. So option C is the right option. Now let's move to the next question. That is question number 2. So in order to solve this question, we are going to use this trigonometric formula, that is cos 2x equals to 2 cos square x minus 1. Okay, so that is from here we can find out the value of cos square x. That will come out to be cos 2x plus 1 by 2. So let's change this integral. So this will come out to be cos 2x plus 1 by 2 whole square. Okay, because this can be written as cos square x whole square. Okay, so this is cos 2x plus 1 upon 2 whole square. So finally it is coming out to 1 by 4. And here it will come out to be cos squared 2x plus 1 plus 2 cos 2x dx. Okay, if you solve it further, so this will come out to be 1 by 4. In place of cos square 2x, if you again apply this, so this will become cos 4x plus 1 by 2. So integral cos 4x plus 1 by 2. Then plus 1, then here you have plus 2 cos 2x. Now you have to simply integrate this one, and finally it is coming out to be integration of cos 4x will come out to be, first half will come outside, and cos 4x will come out to be sine 4x upon 4, and then the integration of this one will come out to be x. Okay, then finally again the integration of 1 is x, and here the integration of cos 2x will come out to be sine 2x upon 2. So this is your answer. Okay, now let's look at the choices. So in choices we have to do some alteration. So for that, let me solve it further. If we solve it further, so this will become 4 to the 8 and 8 to the 32. So 1 by 32 sine 4x, then it will come out to be x by 4, and here 2 also, so x by 8 plus x by 4, and then this will finally comes out to be sine 2x by 4. Okay, so further we can solve it. So this will become, if we take 8 as LCM, so this will become 3x. Okay, 3x by 8, then plus sine 2x by 4 plus sine 4x by 32. Okay, so let's look at the option. So we have here they are taking 8 as common. So again let's take 8 as common. So this will be 3x plus, here it will come out to be 2 sine 2x plus sine 4x upon 4. This will be the answer. So if we look at the choices, so option 1 is the right option. Okay. So let's move to the question number 3. In this question, we are going to use the identity. Okay. So that identity is 2 cos A cos B equals to cos A plus B plus cos A minus B. Okay. So in order to use this identity, I'm going to multiply and divide by 2 in the integral. So this will become half 2 cos 2x and cos 4x dx. Okay. And if we solve it further, so this will come out to be half, and this will become, let's say this is A and this is B. So this will become cos 2x plus 4x. So this will come out to be cos 6x plus cos 2x minus 4x. So this will come out to be cos minus 2x, and cos minus theta is cos theta, so finally it is coming out to be cos 2x d. Now integrating this is very easy. Integration of cos 6x will be come out to be sine 6x upon 6, and integration of cos 2x will come out to be sine 2x upon 2. Okay, so plus c, this will be our answer. So by this will be our answer. Okay. Now let's move to the next question, that is question number 4. So to solve this question, we are going to multiply by conjugate. So this is integral 1 upon under root x plus 3 plus root x plus 2. So conjugate of this will come out to be root x plus 3 plus root x plus 2. Okay, divided by root x plus 3 plus root x plus 2. So in denominator, you can see that a minus b and a plus b. So this will become under root x plus 3 plus root x plus 2 dx, and in denominator it will come out to be x plus 3 minus x minus 2, because outside the bracket x plus 2 it will be minus, so it will be minus, so this will be 1. So finally we have to integrate x plus 3 to the power half plus x plus 2 to the power half. So now this integration is very easy. That will come out to be x plus 3 to the power 3 by 2 divided by 3 by 2, and when you further differentiate x plus 3, so this will become 1. Similarly here also, so x plus 2 to the power 3 by 2 divided by 3 by 2 into 1. So finally it should be come out to be 2 by 3 x plus 3 to the power 3 by 2 plus, so here this should be an option. Okay, so this is our answer. In rest of the here is minus, this is minus, and here is also minus. So this is our only answer. Okay, let's move to the next question. So question number 5. So that's very good question and easy one. So in this question we are going to take log x as t. So this will come out to be 1 upon x dx equals to dt when you differentiate this expression with respect to x. Okay. So finally our integral will transform it like that. This will be sine t dt, because dx upon x will become dt, and at the place of log x you will put t. So integration of sine t will be cos t plus c. Now put the value of t, so that is minus cos log x plus c. So this is our option. So let's move to the next question. So in this question, we are going to follow the Eilert rule, and by Eilert rule, we have log x square into 1 and dx. So this will be treated as first function, and this will be treated as second function. Now we'll apply the rule of integration by part. So this will become first integration of second function. So this is 1 into dx minus d dx of first. So this will be 2 log x upon x, and integration of this 1 dx. So this will come out to be x dx. Okay, so x and x gets eliminated. So here this will come out to be log x whole square, and integration of 1 dx will be x, and here 2 will come outside the outside integral, and integration of log x into 1. Again we'll use integration by part rule, so this will become log x will become first and 1 will become second. So finally this will come out to be log x whole square into x minus 2, in a bracket it will come out to be log x into x, because integration of 1 dx will be x minus d dx of first. So differentiation of log x is 1 upon x, and integration of 1 dx will be x. So x and x gets cancelled out, and at the end it will come out to be log x whole square into x minus, in a minus 2 in a bracket you will get x into log x and minus x plus c. So this will be your final answer. If we go by choices, so this is the right option. Now let's move to the next question. So here, if you look at the function in this question, if you look at the function, if I treat this as our first fx, okay, so it is log sec x. Okay, now differentiate this function, so it will come out to be 1 upon sec x. Differentiation of sec x is sec x tan x. Okay, so sec x gets eliminated, so this is coming out to be tan x, which is our this function. Now we know the property that integral e to the power x fx plus f dash x dx. So this comes out to be e to the power x fx plus c. So if I go by that property, so answer will come out to be e to the power x, and fx is log sec x plus c. So if you see, there is no option, so none of the above is the answer. Okay, this is the final answer, e to the power x into log sec x plus c. So in order to solve this question, we have to follow the Eilert rule. So by Eilert rule, this will become first function and this will become second function. So here sin x into integration of e to the power 2x will be e to the power 2x upon 2 minus d dx of first function, that is sin x. So this will come out to be cos x, and integration of second function, that is e to the power 2x. So this is e to the power 2x upon 2 dx. Now again we have to apply the integration by parts. So this will be first second. So this will, let's treat this as I. Okay. So I though this will come out to be half sin x into e to the power 2x minus half will come outside, and this will become cos x into e to the power 2x dx. Now let's apply again the integration by part rule. So half sin x e to the power 2x minus half, this will come out to be cos x into e to the power 2x upon 2 minus integral differentiation of this cos, that is minus sin x, so this will become plus sin x into integration of e to the power 2x, that is e to the power 2x upon 2. Okay, now we'll have to again integrate it. So this is I equals to half sin x e to the power 2x minus half, this will come out to be cos a half and half multiplied, so this will cos x into e to the power 2x. Again this will be minus 1 by 4, and when we look at this expression, so this is coming out to be e to the power 2x and sin x. So this is our original integration function, so this will be I. So if we transfer this on the left hand side, so this will become I plus I by 4. Now let's take half as common, so this will become 2 sin, and also we can take e to the power 2x as common, so this will become 2 sin x minus cos x. Okay, so 4 and 4 gets cancelled, and yeah, on this side this will become 5i by 4. Okay, then 4 and 4 gets cancelled. Okay, so finally this will coming out to be I equals to e to the power 2x upon 5 2 sin x minus cos x plus c. Okay, so this will be the answer. Let's move to the next question. So this is a very easy one. In this integral, if you take let's say x, if I take x as common, so this will come out to be 1 plus log x. Okay, dx. Now let's take 1 plus log x as t. So this is coming out to be 1 upon x dx equals to dt. We differentiate this function with respect to x. So finally, this above integral is transformed it like that 1 upon t dt. Now, the integration of 1 upon x or 1 upon t is log t. Okay, this is log t plus c. So here this will comes out to be log, at the place of t we can write 1 plus log x plus c. So option D is the answer. Here this should be plus c as well. Okay, so next question is, so this is a definite integral. Okay, so in order to solve this we have to assess the nature of first mod x. So let's take fx equals to mod x. So we know that this will show positive behavior when x is greater than or equal to 0, and this will show negative behavior when x is less than 0. So limit will get split it at x equals to 0. So initially it will go from -1 to 0. Then it will grow from 0 to 2. So here in this range, as it is negative, so this is minus x upon x dx, and here it is x upon x t. So x and x gets eliminated, this will come out to be -1. Here x and x gets eliminated, comes out to be 1. So integration will come out to be minus x, and the limit will go from -1 to 0. Here it is also x, and the limit will go from 0 to 2. Now if we put the limit, it will come out to be 0 and -1. Okay, outside it is minus. Okay, plus 2 minus 0. So finally, as it is -1, okay, so this minus minus plus. So this will be -1 plus 2. So finally it is 1. So option D is the right option. Okay, let's move to the next question. So to solve this question, let's look at the expression, both having power -2x minus 2. So we can rewrite it at 5e to the power -2x dx. Okay, so you know the formula of integral a to the power x dx, that is a to the power x upon log a base e. So this will comes out to be 5e to the power -2x upon log 5e. Now as power is not x, so we will have to differentiate. So this value will come out to be -2. So, and we have to write it in denominator. So finally this expression will be coming out. This will be our answer. So if we go by choices, so option D is the right option. Let's move to the next question. So again, a definite integral question. So in this, we have to go by Euler rule. So this will be our first function, and this will be our second function. So here it will come out to be tan inverse x, and integration of x will be x square by 2, and limit will go from 0 to 1 minus this will comes out to be differentiation of tan inverse x. So this will be 1 upon 1 plus x square, and integration of this x square upon 2 x is x square upon 2 dx. Okay, limit is going from 0 to 1. So this will be tan inverse x into x square by 2, and limit is going from 0 to 1. Here when you integrate this, so this will become 1 by 2, 0 to 1, and this is x square and plus x square. Add 1 and subtract 1 dx. So finally this will comes out to be, when you put the limit in first part, so if you put limit 1 here, so this will be tan inverse 1, that is pi by 4, and 1 by 2. So this is 1 by 2 into pi by 4. When you put 0, so this will be 0 and half. So this integral will become, when you integrate this, so this will comes out to be 1. The integration of 1 is x, and this will be -1 upon 1 plus x square. So this is nothing but, so the integration of 1 -1 upon 1 plus x square will be tan inverse x, and limit will go from 0 to 1, and this will be plus c. Now this is coming out to be pi by 8 minus half. When you put the limit, this will come out to be 1 minus tan inverse 1, that is pi by 4. And then if you put 0, so it will be 0 and tan 0. So finally this will be plus. Now let's solve it. So this will be pi by 8 minus, and this minus minus plus, so this will be again plus pi by 8, and this minus half plus c. So finally it is coming out to be 2 pi by 8 minus half plus c, or we can write it like that, pi by 4 minus half plus c. So at the end it is, there is no option in the list, so option E is the right option. Okay, let's move to the next question. This is again a definite integral question. So in this, we have to assess the nature of this function, which is fx equals to 2, fx equals to x plus mod x plus 2. So if I take this as x plus 2 equals to 0, so x is coming out to be minus 2. So draw a number line and assess the nature of the function with the desired limit. So this is minus 2 and this is minus 3 and 3, because limits are minus 3 to 3. So if you take any point, well, let's say if I take minus 2.5, and if you put it here in this function, so this will coming out to be negative. And if you take, let's say, plus 2.5, so in this range it is coming out to be positive. So the whole limit will get split in two parts. So minus 3 to minus 2, in this range function will be negative. So minus x plus 2 dx, and in this limit that is minus 2 to 3. So in this range function is positive. So this will be x plus 2 dx. Okay. Now integrating. So this will comes out to be minus, I'm taking outside, so this is x square by 2 plus 2x, and limit is going from minus 3 to minus 2, then plus, here it will come out to be x square by 2 plus 2x, and limit will going from minus 2 to 3. And now let's solve it further. So this will comes out to be, if we put the limits, so this will be minus 2 square, that is 4 by 2, and here it is minus 4, and you put minus 3, so it will be minus minus 9 by 2. When you put minus 3, so this will become minus 6, but here it is minus, so this will be plus 6. Now if I take a look at this expression, so when you put 3, so this will come out to be 9 by 2 plus 3 to the 6, and then minus, so this will be minus 4 by 2, then you put minus minus 4, so this will come out to be minus minus plus, so this will be plus 4. Okay, now solve this expression. So this is minus 4 by 2 plus 4 plus 9 by 2 minus 6, and plus 9 by 2 plus 6 minus 4 by 2 plus 4. So here you can see that minus 6 plus 6 gets eliminated, and this minus 4 by 2 and minus 4 by 2 will come out to be minus 4, and then 4 plus 4 is 8, and 9 by 2 plus 9 by 2 is 9. So this is 17 minus 4, that is 13. So if we go by the choices, so option B is the right option. Now let's move to the next question. So again, this is a very good question. Here we are going to use the property of definite integral, that is if a to b fx dx. Okay. So this will be equal to a to b f of a plus b minus x dx. Okay. So by applying that property, let's say this is integral I 1 to 2 root x upon root x plus root 3 minus x dx. So let's say this is equation 1. Now apply this property. So you will get I equals to 1 to 2. Here you can see that a and b, if we sum up a and b, so it will come out to be 3. So this will be 3 minus x upon root 3 minus x plus root 3 minus 3 plus x dx. So equation second, if let's say add these two expressions, on the left you will get 2i, and on the right you will get 1 to 2. In numerator you will get x plus root 3 minus x, and in the numerator you will denominator you will also get root 3 minus x plus root x. Okay, because here 3 and 3 gets eliminated, dx. So these two expressions are same, so it gets eliminated. So let's solve it further. I'm solving it here. So this is 2i equals to 1 to 2 1 dx. So this is nothing but your x limit is varying from 1 to 2. So 2i equals to 2 minus 1. So I equals to 1 by 2. So D is the right answer. Now let's move to the last question of the quiz. So again, this is a very good question. So to solve this question, we are going to do some alteration. So that is pi equals to minus pi by 4 to pi by 4. Inside the log expression, I'm going to multiply it with root 2 and divide it by with root 2. Okay, so this will be root 2 and inside the bracket, I can write it like that, sin x into 1 upon root 2 plus cos x into 1 upon root 2. Okay, so this will be our expression. We know that this is the value of cos 45 and also it is same equals to sin 45. So here I'm going to take sin 45. Now I'm trying to make it this as sin a cos b plus cos a sin b. Okay, so the whole expression will become minus pi by 4 to pi by 4. This is log, this will become log root 2 and this will be plus log, this will become sine pi by 4 plus x. Okay, so this will be our final expression. So here you can see that if I solve this expression, first one, so this log root 2 will come outside and this will minus pi by 4 to pi by 4. So this will be 1 dx. And then here we have minus pi by 4 to pi by 4 log sine pi by 4 plus x dx. So let's solve this expression and treating it as I1. Now let's solve it for I1. So here I'm going to take pi by 4 plus x equals to t. So this will become dx equals to dt and limit will go it like that when x equals to minus pi by 4. So t will come out to be 0. And when x equals to pi by 4, so t will come out to be pi by 2. Okay. So the I1 will become 0 to pi by 2 log sine t dt. And this is very important integral because you have to remember the value of this integral. Otherwise, this question will become a very long. Okay, because this is a separate question. So the value of this integral is minus pi by 2 log 2. Okay, so this is the value of this integral. You have to remember this. Okay, in order to solve the question. So let's get back to the original expression. So this will come out to be, I will come out to be log root 2 minus pi by 4 to pi by 4 into 1 dx minus, and this expression is minus pi by 2 log 2. Okay, so after solving this, we will get here, we can get log half log 2 and this is 1. Limit is varying from minus pi by 4 to pi by 4 minus pi by 2 log 2. So let's solve it. So when you put the limits, so this will become half log 2 and this will become pi by 4 plus pi by 4 in a bracket. Okay, minus pi by 2 log 2. So ultimately it will come out to be pi by 2, and when you multiply with 2, so this will become pi by 4 log 2 minus pi by 2 log 2. And finally it will come out to be, when you take log 2 as common, so pi by 4 minus pi by 2. So finally this will come out to be, so when you take the LCM, this will become 4 and this will become pi minus 2 pi into log 2. Okay, and ultimately this will comes out to be minus pi by 4 log 2. So from the option we can have option B is the right option. So that is a okay. So that's all from my side in this session. If you are preparing for IGIDR 2021 entrance exam, so you can join in our classroom program by calling this number, or you can visit to this link. You have to submit the fee, and before submitting the fee, I would advise watch the trial classes or the demo classes which are available on YouTube and in this link also. After that, you have to submit the fee, and your enrollment request will be approved. For enrollment, you have to download the Teachmint app. So I hope you will like this video, share it with your friend, and subscribe to the channel. Thank you for watching. Stay safe and stay healthy.